Hi, we are going to discuss the topic with state space search. In previous video, we are discussed the introduction in artificial intelligence, and today's topic is planning with state space search. And the topic outline contains the introduction to planning in artificial intelligence and the logic behind that. We have a problem statement, and based on the problem we have to derive a solution based on the search space search, and brief discussion about the planning with search space search. And the introduction about the planning with state space search in artificial intelligence. The state space search, it is a fundamental approach in artificial intelligence planning where an agent explores the different possible states of the world and to find a sequence of actions that leads to goal state. And the planning represents the planning as a search problem, and where each state represents a configuration of the world and actions define transition between the states. The major key concepts of search for search in planning is, we have a state. It is nothing but a representation of the current situation in the world based on the problem statement. And we have to start with an initial state. It is nothing but the starting point of the agent. And we know that finally we have to arrive at the goal state. The goal state is nothing but the desired outcome that the agent aims to reach the final outcome. In between this, the initial state and the goal state, we have to derive so many intermediate states is available. The first one is we called as operators. The operators also nothing but represented as actions. It is defined as the transformations that transition the agent from one state to another. And the next intermediate state is search tree or graph tree. It is a structure where nodes represent states and edges represents the actions. And the path cost, a numerical value that quantifies the cost of reaching a state. The next one is planning with state-based search. The most straightforward approach of planning algorithm is state space search. So in this state space search, we have broadly classified into two types, that is a forward state space search and backward state space search. The forward state space search represented as the progression, and the backward is nothing but regression. The descriptions of actions in planning problem and specify both preconditions and effects for every progression state and regression state. It is possible to search in both directions, so it may be either from initial state, that is a forward from initial state, or backward from the goal state. We can also use the explicit action and goal representations to derive effective heuristics automatically. And the types of states for search includes the main, we already seen that it is a forward state space search, it is FSS search or nothing but the progression. The progression always starts from the initial state, that means the zero state, and applies every action and move towards the goal state. For example, the searches the state space by simulating actions one by one. The forward FSS search or progression is used in the algorithms like BFS, that means the breadth first search, and the A-star search algorithms. For example, if we consider a robot starting at 0, 0 in a grid world and trying to reach a 3x3 matrix. The 3x3 represents, it is the movement includes the upward direction, downward direction, maybe it is a right or left direction. And the backward regression, it is called backward search, BSS search, it is called as a regression. It starts from the goal state, the final state, and it will search us backwards to find the initial state that leads to it. Instead of applying actions, we tries to determine what states could be lead to the goal. and efficient when there are fewer possible goal states than initial states. And the one more is the bidirectional search. The bidirectional search combines forward and backward search to meet in the middle, reducing search time because it starts from the initial state and also from the destination goal state. So we can easily meet the center point of the search algorithm. So common in large state spaces where searching in both directions speed up the process. Thank you.